Hi, everyone. Thank you for attending our breakout session. We're going to do a presentation on how service inventories tie into vulnerability management. If you don't know, cybersecurity engineers have the spiciest memes. So if you take anything away from this, just remember that link in your inbox might be malicious. I'm David Volm, Senior Application Security Engineer.
And I'm Joseph LeGarreta, also a Senior Application Security Engineer.
We both work for FanDuel. Today we're being discussing the importance of a centralized service inventory and how you can use Datadog's tooling in vulnerability management, but also how FanDuel has uniquely used Datadog's log tooling, the existing log tooling, to approach vulnerability management and the service catalog.
So let's start out by discussing some common yet complex questions around the challenges of vulnerability management. Here's a question for the audience. Do you believe that having a centralized inventory of your organization's services and applications is crucial for effective vulnerability management? If you say yes, please raise your hand. Okay, good to see a lot of hands here. And for anybody who did not raise their hand, hopefully by the end of this presentation, you'll be convinced otherwise. As technology evolves, so do the challenges around vulnerability management. Modern IT environments are becoming more complex with the adoption of hybrid cloud, containerization, and microservices. The rapid pace of innovation means that new technologies are constantly being introduced, adding to this complexity. Moreover, the number of vulnerabilities being discovered each year is staggering. In 2023 alone, nearly 29,000 new vulnerabilities were reported to the National Vulnerability Database. This makes it incredibly difficult for organizations to keep track of all of their assets and associated vulnerabilities, especially with a lack of visibility into their entire IT ecosystem and when silos exist between teams and tools.
So how about a real-world example? Imagine you're a doctor who's trying to treat a patient, but you know nothing about their medical history, the medications they're taking, or their allergies. It'd be like you're a doctor that's wearing a blindfold. It's the same way if you don't know what your assets are when it comes to vulnerability management. It's like you're a doctor wearing a blindfold.
So let's dive into what exactly is a centralized service inventory and how can it be of help to us? A centralized service inventory is a single comprehensive repository that contains information about your organization's services, applications, and assets. It provides a unified view of your entire IT ecosystem spanning on-premise, cloud, and hybrid environments, including microservices, containers, and serverless functions. However, a centralized service inventory goes beyond just listing your assets. It also includes key details about each asset, such as metadata, tags, and relationships. It also includes important information such as ownership, criticality, and compliance requirements. With all this information in one place, you can gain a holistic understanding of your IT landscape.
So what are some benefits of a centralized service inventory? Improves visibility and control, enhances collaboration and efficiency, and improves your security, and this results in improving your security and compliance posture. I like to describe these efficiency gains from cross-organizational collaboration as jumping on the bandwagon of developer productivity. Or another way to put it, we want the easy choice and the secure choice to be the same choice. By reducing the manual effort in tracking down these assets and enabling seamless sharing of information across teams, you're able to streamline processes and break down silos. With faster identification of these vulnerabilities, you're able to drive automated remediations and improve your organizational security and compliance posture.
When building an effective service inventory, there are three key components to consider: asset discovery and identification, dependency mapping, and metadata and tagging. The first is asset discovery and identification. This involves the automatic discovery of assets across your environment and involves integrating with existing tools and data sources to ensure comprehensive coverage. With Datadog, you can automate asset discovery using both agentless and agent-based scanning options. Datadog supports diverse environments, including on-prem, cloud, and containers to ensure that you are able to discover assets across your entire organization. The next key component is dependency mapping. By visualizing the relationships between your assets, you can gain a better understanding of how they interact and identify potential impacts of vulnerabilities and changes. This helps in risk management and change management processes. Datadog excels in dependency mapping and visualizations. It automatically creates mappings between your assets, and it also provides interactive visualizations which allow you to explore these dependencies in depth. This makes it much easier for us to gain an understanding of the potential impacts of vulnerabilities and changes. Finally, metadata and tagging are essential for providing context to your assets. By enriching your inventory with additional information, you can enable easier scanning, filtering, and reporting. This makes it easier for you to get the information you need when you need it. Datadog offers a flexible tagging system. You can customize metadata and tags to fit your specific needs and integrate with external CMDBs and asset management tools. This makes it possible for your service inventory to always be up to date and aligned with your existing processes.
So just like the example of the blind doctor, you can't effectively manage these vulnerabilities that you're finding if you're not able to tie them to a service inventory. If you don't know what's running, where it's running, when it was deployed, inventory management provides that foundation you need to do proper vulnerability management. Now let's look at some real-world insights from FanDuel. Integrating vulnerability management with our service catalog has been a game changer. Now we're able to prioritize our remediation efforts based on risk and impact and understand the criticality and exposure of our vulnerabilities. When we first started to solutionize this, we're looking at a pretty basic approach. The vulnerability management product at Datadog didn't even exist yet. So we just started sending raw Datadog logs to the Datadog logging product. We took Cyclone DX SBOM, a software bill of materials, contains a compiled list of every dependency in your dependency tree for a project, and also includes a vulnerability annotation, which I've highlighted here. And that vulnerability annotation, we take each one of those vulnerabilities in our scan results and merge the JSON with the service Datadog YAML, which provides the team, context, tier of service if it's running in production information. So then with all this information all in one place, we're able to do these sorts of queries. So just looking at top 10 count on critical vulnerabilities. So we just want to find where's our critical vulnerabilities at in all of the services that we have. And this is through that merging of our service catalog data. So here we can see this web app is the most critical vulnerabilities in a service. You can also see that the org name up there is completely fictional, and we'll go into that in a little bit. This is not an actual web app at FanDuel. And so we dig into this web app here and we look and see, oh, the lifecycle on this is deprecated. Okay, so this probably isn't as important. The sky is not falling yet. Then we can now do, because we've got this service catalog information here, we can further refine this query and we can say, all right, We just want to find tier 1 production critical vulnerabilities. And now we see the real risk to our organization here is customer support application. So scanning through all those criticals, we had a top 10 list. Now we've narrowed it down to one service that's in lifecycle production. And if you look on the previous here, that customer support service was not even in that top 10 list. So we've found this actual risk, what didn't come up in the initial results. So now here's a demo that we're going to do, and this is how you can apply these lessons learned to your own organization.
So today we're going to demonstrate how to set up Service Catalog in Datadog and 2 different approaches to vulnerability management. For this demo, we're going to be using a fictional organization called Puppyflix, a streaming service for dogs. So the first step to setting up Service Catalog is to go to the source code integration page. We're going to scroll down here and we're going to click Link New GitHub Account. After that, we're going to input the name of our organization, Puppyflix. We're going to scroll all the way down to Service Catalog, and we're going to check that box. This grants Datadog the permissions it needs for Service Catalog to function. In this case, it's requesting read permissions to our repository contents and permission to receive push webhook events from GitHub. We scroll all the way down, confirm our permissions, and we hit Create App in GitHub. After that, we're automatically redirected to GitHub to install the application. We go ahead, select all repositories, and hit Save. Now, all that's left to do is add a service.datadog.yaml file to all of our repositories. This file is what Datadog uses to populate its service catalog. This is a very bare bones example of a service.datadog.yaml, but there's all kinds of keys and attributes that you can add here, including custom ones. In this case, we're just going to focus on a couple of attributes, the DD service, which is web app, and the tier, which is 1. So now we head on over to the service catalog, and as we can see, all of our services have been populated. And here we're going to do a query for just tier 1 applications, and as we can see, our web app pops up that we were just looking at a couple slides ago. You should also know that the Datadog Service Catalog offers a visual map functionality where you can see the relationships between your services. So now that we have a working service catalog, let's explore vulnerability management. First, we're going to explore enabling the built-in software composition analysis feature, or SCA, in Datadog. It's very quick and easy to set up, and best of all, there's no coding required. So first, we're going to head over to the vulnerabilities page. We're going to click Enable Software Composition Analysis. Here we can see that software composition analysis is currently not enabled, so we're going to click Select Repositories. And here we're going to toggle where it says Enable Software Composition Analysis. However, if you'd rather, you can scroll down and just toggle the specific repositories you need. So once that's done, we head back on over to the vulnerabilities page and we click Library Vulnerabilities. And as we can see, we've got a bunch of vulnerabilities to go through here. We're going to do a filter on this for our tier 1 application web app. And as we can see, web app has 90 critical vulnerabilities and 130 high. We better patch those up quick. And that's it for Datadog SCA. Now, what if you want to use custom scanning tools? Maybe you want to have custom attributes added to your vulnerability results, and maybe you want to create some visualizations, some dashboards with those custom results. Well, we're going to explore a method that we used at FanDuel of sending vulnerability data to Datadog using logs. We're going to do a demo of this using Gripe, an open source vulnerability scanner, but the same principles will apply with any tool. So here is a quick shell script I wrote called puppyscan.sh. It scans all the repositories in the PuppyFlix GitHub organization with Gripe, formats the results into an arbitrary JSON format, and sends them as logs to Datadog using the HTTP API. The API is a great method of getting logs into Datadog without the use of an agent. However, at FanDuel, we ran into some issues with this when sending large volumes of logs. It ended up being really slow because every time you send a log, you have to open a connection, send the log, close a connection. So we found out that Datadog offers an alternative. You can actually send logs via a raw TLS socket. So you just open the socket, send all your logs, and then when you're done, you close it. This turned out to be nearly instantaneous, even when sending thousands of logs at a time. So once our script is finished running, we head on over to the logs page in Datadog. As we can see here, we have a bunch of vulnerabilities to go through. We're going to do a filter using one of our arbitrary JSON fields, CVSS score, and we're going to filter for all vulnerabilities with a score greater than 9. We can go ahead and click on one of these vulnerabilities and see some additional information such as the repository, the vulnerability, the package version, and even the file that the vulnerability resides in. Now we're going to explore a dashboard that I created using these vulnerability findings. At the top here, you can see unique vulnerabilities by service. In this case, the social sharing service is responsible for a majority of the vulnerabilities. Below that, we see top 10 vulnerabilities by appearance. And in the bottom right corner, we have vulnerabilities by team. As we can see, the community team is responsible for most of the vulnerabilities. So let's dig into that a bit. We click on the community wedge of the pie chart here, and then we click View Related Logs. And as we can see, it appears that the community team is responsible for the social sharing service. This makes perfect sense, knowing that the social sharing service is responsible for a majority of the vulnerabilities of PuppyFlix. And that concludes our demo. So we've covered how to set up Service Catalog in Datadog, along with 2 different methods of vulnerability management.
Now we're going to go over best practices, future outlook, key takeaways. So start with the critical services first. You don't have to boil the ocean. You can start where the critical risks to your business are, look it through a business risk lens, start out with those services first, and then gradually expand that coverage over time. Then it's really, really important, not for just security, but anything in Datadog, get your naming convention and tagging strategy right. Make sure everything's tagged consistently, or you're going to have a bad time with this. And you want to keep this service inventory regularly updated, implement automated discovery and synchronization as we showed. You can install the Datadog GitHub app, and that will keep these service Datadog YAML files up to date. And you want to also conduct periodic manual reviews and audits, because you can have your service catalog say one thing, but what's actually running in production can sometimes drift. So you want to make sure that you have those manual reviews in place. Then you want to collaborate with cross-functional teams. As I said earlier, jumping on that bandwagon of developer productivity, you can drive big wins for security by collaborating with other parts of the organization that also span multiple teams. And you can foster that culture of shared responsibility and transparency throughout your organization. So to wrap this up, centralized service inventory is crucial for vulnerability management. Without it, you're just like that blind doctor trying to diagnose someone without knowing anything about them, wearing a blindfold. And Datadog has some powerful capabilities for vulnerability management, automated asset discovery, dependency mapping, metadata tagging. But don't be afraid to try like a custom solution like we did at FanDuel. Datadog's logging product is very powerful, very flexible. You can build a lot of cool things with just the logging product. And best practice for success, get all the context you can, and you can drive a lot of this with the service catalog. Is this service running in production? Is this mission critical? And then finally, collaborate with those cross-functional teams, jump on that bandwagon of developer productivity, make security make security the easy choice. Like, make this your default thing that developers go to. Like, they grab an off-the-shelf solution, your golden path at your company, and it's secure by default. Now we'll open it up for questions and answers.
Thank you. All right, do we have any questions in the room?
Do you have any advice for organizations who maybe aren't comprehensively migrated to microservices and still have a monolith? How might you go about identifying owners if it's not a one-to-one relationship between service ownership and SCM repository?
Yeah, that's a good question. I'm not sure the specifics of the Datadog version of this, but if you were to look at doing the custom bit like we were looking at, one approach that we've done for larger monorepos is break down by file path. So we could tag like this vulnerability was found in this path in this larger monorepo project. Because with a monorepo, a lot of times you'll have like different teams working on different like subfolders in the project. So there is some structure there. And whatever structure you can find in your organization, you could tag it that way. And I think that's where like the custom solution shines a little bit, is you're able to customize that.
Thank you.
Yeah.
Thank you. Any other question in the room? If not, I have a last one. So how do you go about going from a state where you have no service inventories to having each and every service with their own service definition file? How do you go about that? Because it sounds quite complex, especially if you have a lot of services that are managed by different teams.
You want to take that?
Sure, yeah. So at FanDuel, we actually have a central repository with a mapping of all of our teams and business units and all that stuff. So we're able to validate service inventory files against this. And of course, if there is no service inventory files at all, that process is a little more difficult. But I mean, yeah, when I came to the company, we already kind of had it in place. So, you know, I'm not sure what kind of work went into that exactly. I don't know if you know more about that, David.
Oh, yeah. I mean, the main thing with like mapping teams is just like first you get the teams in there, and you got to find like what services are unowned, like what's the stuff that's running in production that nobody's really claiming. So that there's always a few parts to it. And then if a team moves or changes names or something, that's also another thing. Like, okay, this team changed names, but now the services that they own have been kind of orphaned. So yeah, our strategy to just having like a central list of what those teams are, it allows us to produce that like validation that our service catalog is good.
I suppose another thing I should mention is a lot of the teams, they make use of GitHub tags for repositories. So, you know, say there's not a service.datadog.yaml file, but I can see that repository was tagged with a specific team name. Then I know who to contact and be like, hey, add that file to your repository.
Great. Thank you. So thank you, David. Thank you, Joseph.